Hello dear students, we have been studying the adsorption isotherm. Now we'll see the definition of adsorption isotherm. That was the definition of Freundlich adsorption isotherm. The relationship between the amount of gas adsorbed by unit mass of adsorbent with pressure at fixed temperature can be expressed by a measure of a curve termed as adsorption isotherm. So this relationship as well as this curve both can be considered as a adsorption isotherm. Isotherm means constant temperature, so we always keep the temperature constant for each adsorption isotherm. So for various temperature we get different curves. As we have seen, x by m is equal to k into p to the power 1 upon n. If we take log both the side, log of x by m is equal to log of k plus log of p to the power 1 upon n. Now log of x to the power something, that is 1, that power multiplied by log of x. So log of p to the power 1 upon n is nothing but 1 upon n log p. So we can write it this way: log of x by m is equal to 1 upon n log p plus log k. Again, this is a kind of equation which is y is equal to mx plus c. So here your x axis is log of x by m, your y axis is log of p. The slope of the curve will be 1 by n and log k will be the y axis intercept. So if we can plot a graph this way. Now if we plot a graph of x by m versus log of p, we get a straight line whose y axis intercept is log p and slope is 1 upon n. You can see here, my dear students, I have already plot a graph for you. From this you can see that this is log of x by m, which is on y axis. This is log of p. We get a straight line. The slope of this straight line, that is b by a, is equal to 1 upon n, and this is the y axis intercept, that is your log k. This is what it is according to the Freundlich isotherm. Explanation of Freundlich isotherm. So let us try to understand what does it represents, or what does the Freundlich isotherm explain us. Freundlich isotherm explains the behavior of adsorption in approximate manner. Look at the graph again. This is behavior of adsorption, not adsorption, adsorption. Behavior of adsorption in approximate manner. Look at the graph again. You can see that there is a graph of x by m versus p. This graph is almost straight line in this part. It starts with the origin and then it goes parallel to the x axis in this case. So this is what it happens at high pressure. At high pressure the graph is parallel to the y axis, and at low pressure the graph is almost linear. So we can say x by m versus p graph indicates that, or x by m versus p curve indicates that at low pressure and zero pressure, x by m proportional to p to the power 1 when n is equal to 1, or 1 by n is also equal to 1. It means that curve is almost straight line and the x by m varies with p linearly. But now what happens at high temperature? Let us try to understand. At certain pressure, which is high pressure, x by m proportional to p to the power 0. That means x by m is equal to k, because p to the power 0 is equal to 1. When you have p to the power 0 is equal to 1, your 1 upon n, where n becomes infinite. Thus the extent of adsorption x by m become independent of pressure at certain high pressure. It means that your n is equal to infinite value, and 1 upon n, that is 1 upon infinite, that is equal to approximately 0. So this is the condition where there is equilibrium between adsorption and desorption takes place, or this particular condition is also known as saturation. Now if we increase the temperature, it does not make or bring any other changes. When the rate of adsorption and desorptions are same, such condition is called saturation. Limitations of Freundlich isotherm. What is the limitation? Freundlich isotherm is failed to explain the behavior of adsorption of gases on solid at high pressure properly. like when the condition is called the saturation. Now we'll understand about the adsorption from solution phase. We know that in the solution there are solute and solvent. Now if we put some good adsorbent into the solution, the adsorbent adsorb solute present in the solution, that is solid. Adsorbent can adsorb solute from the solution phase. So if we put any adsorbent into the solution, the solid particles that is present into the solution which are which are solute, they can be adsorbed on the adsorbent, and thus again there is adsorption into the solution and the concentration of solute into the solution decreases. When we put charcoal in acetic acid solution, in water the concentration of acetic acid solution decreases because acetic acid is adsorbed on the charcoal. These are the examples. Litmus solution, when shaken with charcoal, the solution become colorless because the solution is adsorbed on the surface of charcoals. Precipitates of magnesium hydroxides are white in color. The precipitates of magnesium hydroxide, which is also known as milk of magnesia, turns blue when precipitated in the presence of magneson. Magneson is the name of the dye. Magneson reagent, the color is due to the adsorption of magneson on precipitates of magnesium hydroxide. These are the three examples by which we can understand the adsorption into the solution. I hope, my dear students, you are enjoying. Happy learning.